Okay, so let me get to the front of our notes. So notes 3.1. So I'm starting right here at the beginning of our notes. Right here. Lesson 3.1. So yesterday your video, I see the screen's frozen. Thank you. Yesterday your video started off with square roots. Yesterday we only talked about square root functions. Today we're going to focus on a cubic root. Today we're going to focus on a cube root function. Okay. So yesterday, hopefully you guys noticed that when you do the square root, you see that you can also write the square root as x to the power of 1/2. I made to show you that, right? That's called a rational exponent, and that's going to be our next lesson. We're going to do rational exponents as part of a review, because I don't know if you guys got that in Math 1 or not, okay? So now let's focus on taking something to the cube root, a cube root. Well, this cubic root can also be written as y to the equals x to the power of 1/3. And so I don't know if you can tell, but that is a exponent. That 1/3 is an exponent. So the exponent 1/3 means the same thing as the cube root. So I think it's important to think about cube roots. So if I were to take the number -1 and I were to cube it, what does that mean? Well, it means multiply by itself 3 times. That's what I wanted to hear. It's still -1, yes. What about -2 cubed? -2 times -2 is +4. Yeah, it's going to be -8. So guess what? You can find the cube root of a negative number, whereas you can't find the cube root of the square root of a positive, or you can't find the square root of a positive number, but you can find stop. You cannot find the square root of a negative number, but you can find the cube root of a negative. I got it figured out. Sorry, guys. So yeah, you're welcome. So let's make a table of values, and we're just going to take the cube root of it. So when I think about my table, right, this is whatever x I'm putting in, and I'm taking the cube root of it. So let's see. If x is -27, this is saying what number did you multiply by itself 3 times? What number did you multiply by itself 3 times to get -27? -3. -3 times -3 is +9 times -3 again. Okay, so hang on a second. Let's talk about what a cube root means. If I said, what is the cube root of x cubed? What would you guys tell me? Because some of you guys are making faces. Okay, well, hang on a second. If I said, what is the square root of x squared? What would you tell me? It's x. Okay, hang on. What is the square root of 25? Okay, so let's look at this. The square root of x squared equals, we learned that we could write this as a product. How many factors are being repeated? 2, and they're exactly the same. That's why it equals x. It's just like simplifying a radical. So if I think about the cube root of -27, that is the same thing as saying the cube root of -3 times -3 times -3. When you have a square root, you need 2 of the same factors. When you have a cube root, you need 3 of the same factors to pull it out. Okay? So the cube root of -27 is -3. Let's look at the cube root of -8. So cube root of -8, well, that's the same thing as saying the cube root of -2 times -2 times -2. Yeah. So I have to have 3 of the exact same factors to get it out of the root. So this is -2. The cube root of -1, well, we just showed up here that -1 times -1 times -1 is -1. The cube root of 0, well, that's just 0. What about the cube root of 1? 1. The cube root of 8? 2. The cube root of 27, 3. Notice that we're only talking about numbers that are perfect cubes. We're only looking at numbers that are perfect cubes. Okay? So let's look at the pattern. And I'm going to start with the positive numbers first. Just going to look at the pattern. So we start at 0, 0. That's our beginning point. So I'm going to plot that point. And if I move 1 unit to the right, I go up 1. 1 unit to the right, I go up 1. I can't make it big enough and still see my writing. I'm sorry, you guys. I'm trying. I'm trying. So if I go 1 unit to the right, I go up 1. If I go 8 units to the right from the origin, 1, 2, 3, 4, 5, 6, 7, 8. Well, the cube root of 8 is 2. So I go up 2. And my x-axis doesn't go out all the way to 27, right? It just doesn't go all the way out there. So this is the positive side of my graph. But this graph also lets me go to the left because I can go negative. So if from my starting point, I go 1 unit to the left, I go down 1, negative 1. If I go 8 units to the left, I go down 2. 8 units to the left, down 2. And again, I could go 27 units to the left, but my graph doesn't let me go out that far. So your cubic function makes this kind of weird looking zigzag. Little wave. I like it too.
It reminds me of like a tornado starting to form or something.
Yeah. So the pattern, I'm going to write out your pattern. So I'm going to do the positives first. If you go 1 unit to the right, you're going to go up 1. If you go 8 units to the right, you go up 2. And then if you go 1 unit to the left, you go down 1. And if you go 8 units to the left, you go down 2. That's your pattern. You have both positive. I'm going to try and kind of highlight it. You have positives. These are your positives to the right. Positive right. And then this is your negative left. So I'm going to say right and up or left and down. Okay. So let's talk about the domain. Tell me what the domain stands for. We said it yesterday over here when I did my notes really neatly on lunch. All your x values, right? So if you look at your graph, what are the x values that are in your graph? So all the negative numbers and all the positive numbers, right? How do we say all the negative numbers and all the positive numbers? All real numbers. D, and then I can just do this. Real numbers. Disappeared. All real numbers. If I were to show this in interval, as an interval, how do I write this as an interval? What's the smallest real number that we know of? Negative infinity. What's the largest real number we know of? Yeah. I write it like that because it looks like someone with like glasses and a, I don't know, just in a little nose. It's so cute. Okay. What about the range? Let's look at our range values. I don't know. What about the range? How far is your y going to go on the positive side? Forever. How far is it going to go on the negative side? Forever. It's got arrows on the end. Forever. So your range, your y values, right, in case you forgot what your range is also all real numbers. You write it as negative infinity, positive infinity. Okay. Okay, flip flop over. So yesterday I did all of this in our video. I did all of the functions, even the cubic functions, because I wanted to make sure that you guys understood the transformations. Remember that this transformation applies to any function. It works for linear, quadratic, exponential, cubic, everything. Okay. So if you add, this is saying, so this f of x, this is like, hey, this is the function, whether it's a square root or a cube root. If outside of the root, you add a number or you subtract a number, you move it up or down. That's what that's saying. These next two are saying, hey, if your function is a square root or even a cube root, and you have some number that you add or subtract inside the function, you move opposite. If it's plus, you move to the left, and it's minus, you move to the right. That's what this is saying, okay? And then this negative value right here outside of the function, that's your a value, and that tells you that you're going to reflect over the x-axis. For those of you guys that have your heads down, you're falling asleep, you're resting your hand on your face, get it off or go stand up, because you're falling asleep and then you're not going to do your homework and you're going to get a crappy grade on your quiz and you're going to be like, I don't know why. Well, because you're not paying attention. That's why. Okay. I did example 1 and 2 for you because they were square root functions. Let's do example 2. So I'm starting with a cube root function. I have this cube root function right here. And we're comparing f of x, it's just the parent cube function, to g of x. So notice that I have something on the outside and I have something taking place inside the function. So what does that negative on the outside tell me? What does this negative on the outside tell you? It's reflecting. Yeah. So this is going to, this negative tells me that it's going to reflect over the x-axis. Okay. What does this tell me? This -2 inside the function. It's actually going to be what? Say that again. Moves to the right. Yeah. Moves 2 units to the right. Okay. And that's it. So what's your starting point going to be? What's your HK value going to be? Well, if you typically start at 0, 0, but you move 2 units to the right, that's changing your x-axis. So your new starting point is the ordered pair 2, 0. This is your starting point. This is H, K. Okay. Questions about that? Okay, good. You're good. Go to example 5a and 5b. You can skip 4a and 4b. I already did those yesterday. Those are square root functions. We want to go to the cube roots. Okay. So we're going to talk about, here's kind of like the process. Every single time we're going to talk about what the movement is. So I'm just going to write moves. We're going to give the new starting point. We're going to write down what the pattern is. That'll help you. And then we'll graph it. Sound good? Every single time. So what kind of movement does this represent? To the right 5. So we're going to go right 5. So if I originally start at 0, 0, and I move to the right 5, what's my new starting point? It's 5, 0, and I even plotted it. It's 5, 0. Okay. I'm going to do my pattern right here. So remember, I move 1 unit to the right or 8 units to the right, but I also move 1 unit to the left and 8 units to the left. So if I move 1 unit to the right of my starting point, how much do I go up? 1. 1 unit to the right, up 1. If I move 8 units to the right, what is the cube root of 8? Up 2. So if this is at 5, 5 plus 8 is like 13. So I'm going to just put it right here. I'm going to just kind of graph it off my graph. It's not going to be perfect, but I'm going to put it there anyway. Now I'm going to do my movement left. Left 1 unit makes me go down 1. Left 8 makes me go down 2. So left 1, down 1. Left 8, 5, 6, 7, 8, down 2. So when you connect your points, you actually have this graph that kind of comes up like here, hits your starting point, and goes like this. All cubic functions are like that. They make a little wiggle. I call that a wiggle. What it's doing in the axis is a wiggle, right? If it's a straight line, it crosses. If it wiggles like that, changes direction, like instead of increasing, it changes to decreasing, it's a wiggle. And if it's just touches the axis, it's a bounce, right? So this is a wiggle. Let's look at the next one. We're going to talk about movement, new starting point, and pattern. So the first thing I want you to do is I'm going to rewrite this. I just want you to know that this is the same thing as f of x equals the cube root of x plus 3. And I see that there's a negative out in front of it. Do you guys see that negative out in front of it? See that right there? Okay. So let's talk about the movement. What's happening? To the left 3. I love that. Okay. What else? What does that negative out front do? It's going to reflect. Yeah. Reflect over the x-axis. And I'm also going to write, since we call that a, we call that value a, I'm going to write that a equals -1 because that's what I use to change my pattern, right? That's my multiplier for my pattern. Okay, so let's talk about our starting point. If I originally start at 0, 0, and Tyler told me I moved to the left 3, what is my new starting point? Yep. So h comma k is -3, 0, I think is what you wanted to say. I know you knew that. Yep. -3, 0. That's where I'm going to begin. That's where my wiggle takes place, where I change, right? Change my direction. So if I move 1 unit to the right, I typically in my pattern go up 1. And if I move 8 units to the right, typically in my pattern, I go up 2. If I move 1 unit to the left, I typically go down 1. And if I move 8 units to the left, I typically go down 2. But remember that your pattern always gets multiplied by a, and a is -1. So now if I move 1 unit to the right, I'm going to put like a squiggle here. So now if I move 1 unit to the right, my pattern up 1 times -1 means that I'm going to go 1 unit to the down, like right? Instead of going up 1, I'm going to go down 1. And instead of moving 8 units to the right up 2, I'm going to go 8 units to the right down 2. That's how I reflect over the x-axis. And then I'm going to change the direction on the negative side. If I go 1 unit to the left, instead of going down 1, I'm going to go up 1. And if I go 8 units to the left, instead of going down 2, I'm going to go up 2. So I'm going to start at my starting point. And if I go to the right 1, I actually go down 1. And to the right, 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2. If I go to the left from my starting point 1 unit, I go up 1 now, it changes direction. And if I go to the left 8, I go up 2. So your graph looks like this. Wiggle. What do you think?
I think it's craziness.
Craziness?
Yep.
Okay. I want to talk to you about domain and range for each one of these functions because we didn't do that. So I'm going to shrink both of my graphs up and we're going to talk about the domain and the range for each one of them. Remember that your domain is your x values and your range is your y values. So what is the smallest x value you see on the first graph? Yep. Going to go on forever. Look at that arrow. It's pointing to the left, to the left. -infinity. So we say it's all real numbers or we use interval notation. -infinity, +infinity. And what about the range? All real numbers. Or we use interval notation. -infinity, positive infinity. I feel like every time we've done the domain and range on a cubic function, it's been all real numbers. What do you guys think? Yes, it has. The domain and range of cubic functions is always all real numbers, or negative infinity, positive infinity. Thoughts? Are we okay with that? Okay. I have 2 more examples, and Trey leaves in like 14 seconds or so. Trey, take a look at this one. Trey, look at the board up there. Tell me, where is the starting point? Where do I start? Where's the wiggle taking place? It is at 2, 5. That's where it's beginning. That's where that change is taking place. So remember, I started at 0, 0. And if the new point is 2, 5, that means that I moved how much to the right? From 0, 0, 2. And how much did I move up? 5. Right 2, up 5. So how do I show? I know it's a cubic function, and it's still 1 unit to the right, up 1, 1 unit to the left, down 1, 8 units to the left, down 2. So it's still following the same pattern. How do I write this function to show that I'm moving to the right 2? It's a cubic function, to the right 2 and up 5. What am I putting? If I'm moving to the right 2, that's happening inside the function. How do I show that I'm moving to the right 2? It's the opposite. X minus 2. Good job. And then plus 5 on the outside. Good job. Good job. Good job. Okay. So this is our H and K value. This is our starting point. Domain and range. What do you think it is? All real numbers. All real numbers. Okay. Are we good with that? Okay. I'm going to move down to these last 2 that I don't think we did yesterday. I did all of this. Did I not do any of this with you guys yesterday? No, I did not. Okay. So we're going to state the domain and the range. We're going to state the domain and the range. So I think it's important to to write down the starting value. Write down the starting value. So I'm going to put up above this H and K, and I'm just going to try to put the ordered pair where it starts before the domain and range so we can think about it. So if this number, David and Trey, good luck. Have a great time. So if this number out front is a constant, is that making it move to the left or to the right? Is it making it move up or down? Is it making it do anything at all? No, it's just stretching your output. So this still has a starting point of 0, 0. So think about your square root functions. Think about your square root functions. If the starting point is 0, 0, that means that all of my x values have to be greater than or equal to 0. And we write it in interval notation as 0, comma, positive infinity. And my range, all of my y values are also greater than or equal to 0. Interval notation, 0, comma, positive infinity. Are we good with that? Yeah? Okay. What's the starting point here? Tell me what's happening inside the function. -1. I move to the left. This means left 1. So it's -1, 0. So my x values are greater than or equal to -1. Or what are they? What kind of function is this? What kind of function is this? It's a cube function. And what do we say the domain and range is of all cube functions? All real numbers. All real numbers. I don't know why that disappeared. All real numbers. Okay. This next one, square root function. We got 2 things happening. 2 things happening. This makes it reflect. And this makes it move right 7. So x has to be greater than or equal to 7. And my y values, instead of being greater than 0, are now, they're flipped over the x-axis. So they're all now going to be less than or equal to 0. So 7, comma, positive infinity with a bracket and a parenthesis. That's your domain. And your range, all numbers that are less than or equal to 0. So remember, when you do interval notation, the smallest number has to come first. So what's the smallest number? Like, what's the smallest number in the world? Negative infinity. Yeah. What's the largest number in our range? 0. All of those numbers are less than or equal to 0. So you have to write this negative infinity first and then 0. Okay. Are you with me? Okay. Example D is also a square root function. Let's talk about our movement. What's happening inside? Left 2. And what else? Down 3. So the down changes the y, the left changes the x. So -2, -3. But it's not reflected. So that means that my smallest x value is -2. So -2, comma, positive infinity. And my smallest y value is what? -3. -3, positive infinity. Okay. Let's look at this next one. What is happening? What's happening? What does this minus on the inside mean? Yeah, 1 unit to the right. What's this plus on the outside mean? 6 up. So if I start at 0, 0, and I move to the right 1, I'm now at the ordered pair 1. And if I move up 6, yeah. So my smallest x value is now 1. But look at this guy right here. What does that tell me to do? What? Reflect. So this is the largest y value. Everything else is below that. How do I show that 6 is the largest y value? How do I write that? Negative infinity. And then 6 with a bracket. Hang on. Someone else just asked me if they go to the restroom, and I asked them to wait a second. Okay, so can we talk about homework really fast? Cool. As soon as I go through homework, you can go. Okay. All right. So homework. Yesterday, you did not do this. So this is what you're doing today. You're going to complete that question, right? And then you're going to do this graph because we didn't do that yesterday, right? And then we're going to do question 3, 5, 7, 8, 9, and 10. And that's great because you have, and 11, you have 35, 40 minutes. You have 40 minutes to complete 1, 2, 3, 4, 5, 6, 7, 8, 9 problems. 45 minutes to do 9 problems. If you're asking me to go to the restroom, you're the third in line. You have 9 problems. And do you see on question number 11, I put rewrite this. Rewrite this. I want everyone to look at question number 11. Do you see how they put that 5 first? Do you see how I rewrote that? I want you to rewrite that. Think about what's actually happening. We're adding 5 to the function. Don't put it at the front. Good luck. Okay? You guys are awesome.